Hello and welcome. In this series of videos, we will take you through the simple steps to implement your own AI-based image processing with the all-in-one solution IDS NXT Ocean. If you're not already familiar with NXT Ocean, we have a video which you can access via this link, which provides an overview and introduction to the features and benefits. These videos will cover the 4 basic steps to your solution: grab, label, train, run AI. First, we will cover the grab element, in which we will acquire our images and then upload them to our web-based service NXT Lighthouse to assign labels and annotations to the image data for both classification and object detection tasks. With our dataset created, we will then see how to train the neural networks, and then once this is complete, we will take the neural networks and upload them to the NXT camera and run AI. In these tutorials, we will build AI solutions for classification and detection of different nuts. So let's look at building our datasets. So first we start NXT Cockpit to connect to our camera. The NXT Cockpit software provides a number of features and controls, and whilst the detail goes beyond the scope of this tutorial, we'll have a high-level look at these now. So we start by selecting our camera and logging in. Now, the first page is the dashboard, and this is used to monitor a number of system parameters and is also available as a web service and can be seen remotely from any system on the network and doesn't need to have the NXT Cockpit software installed. Then we have the configuration page, where, as would be expected, we can find all of the system parameters covering things like the sensor configuration, network setup, user access control, setup for external interfaces, and management of the vision apps installed on the NXT. And finally, the logbook, where the NXT can be configured to log system information during running. For the dataset creation, we will go to the configuration page and then select the VApp manager on the left-hand side. Here we see a number of VApps ready to go, and right now we shall use the crawler VApp. This is the NXT camera-based service that will transfer our acquired image data to the host PC over the network connection. So we select this and set the status to running. So if we now select the crawler using the icon that has now appeared on the left-hand side, we see the interface to this vision app. We have one additional step, and this is to start and configure the corresponding crawler utility on the host PC, which is installed with the NXT Cockpit software and will create the link between the NXT camera and the folder on the PC to which we wish to transfer the images. We do so by clicking the settings icon in the top right corner and selecting IDS NXT Crawler, and this will start the utility on our local PC. You can also start this from the IDS NXT program group directly. There are just a couple of settings to configure here. Firstly, we select the correct network address for the interface, and you can check against the IP address of the camera displayed in NXT Cockpit, where the first 3 numbers should match. And then we set the path on our host PC where the images should be transmitted, and then start the crawler utility. We can then simply copy the URL that is automatically created and paste this into the URL path in the configurable section of our crawler VApp. So now our NXT camera knows where to send the images, and we are now ready to go. So the camera section within the Crawler Vision app shows a live image preview and gives the opportunity to optimize the image. So we can make sure the lens is focused, and if we need to, we can adjust exposure, gain or white balance, or apply image flipping if that's required. And depending on the use case, we can acquire from the NXT camera in free run mode or in triggered mode. So triggered mode is useful if the objects to be imaged are not continually in the view of the camera, for example on a production line. So a hardware trigger can be sent to the NXT camera to acquire an image when the object is in view. In other cases, you may choose to use free run mode, providing a continual stream of images, or just manually trigger the acquisition with the software trigger button. So back in the VApp section, we need to set the class name for our first class of images. In this case, it's walnuts. And by enabling the save switch, we can start to acquire images and transfer them to the host PC. We can acquire the full image, or in this case just a region. And as we acquire the images, the image transmitted count increments, so we can keep an eye on the total number of images we have taken. For applications with multiple classes, it's simply a case of changing the class name when acquiring images of the other objects or cases, so these are transmitted to another subfolder with the appropriate name. And we'll see the benefits of this in the next video. We will have a video soon on our YouTube channel that provides some guidance on best practices for generating a good dataset. The key factors are that we need to have the variability represented in the dataset. So in this example, we can see the full range of objects as well as changes in background and lighting. We should also aim to have a similar number of images in each class. How many this will be depends on the application. It could be 50 per class or hundreds. But we can also start with a few tens of images just to get some idea if deep learning is a suitable approach. And if possible, use the same setup for the training images and for the application. Although if you have a database of images already, these can be used. You'll just have to follow the same steps from the next video onwards. Now that we have acquired all of our images for our dataset, we can stop the Crawler V app running on our NXT camera and stop and close the Crawler app running on our host PC, because we no longer require these. And let's have a look at the resulting image folders. So the first thing to note is that each image acquired also has an associated JSON file. These JSON files contain image metadata, but they're not required for these demonstrations, so we can ignore these for now. And we can quickly preview the images to check we have a good variation and no obvious mistakes, like the wrong image in the wrong folder, or perhaps if we were running free run mode, we might identify and remove any images that are very similar. And this completes the image dataset creation part of our tutorial. In the next video, we will take our images and see how to upload these to NXT Lighthouse, our cloud-based AI training software, and how to apply labels and annotations. Thanks for watching.